Banks have a huge document problem. What if a team of AI agents could actually understand them? The old way was a rigid one-way street. The new way? It's all about teamwork and collaboration. So what does agentic really mean? Well, think of it like a team of AI specialists all working together. All right, let's meet the team. Who are these AI specialists and what exactly do they do? First up is the document understanding agent. Its job, figure out what the document is and pull the raw info.
Next, the validation agent steps in. This one's the fact checker, making sure every detail is spot on.
Then you've got the enrichment agent. This is where the real magic happens, adding context and deeper insights. Okay, so how does a document actually move through this team? Let's follow its journey step by step. It's pretty straightforward. A document gets uploaded, then our agents extract, validate, and enrich all the data. And what's cool is this creates two totally different, super powerful ways to store everything. On one side, structured data for simple filters. On the other, vector data for smart, meaning-based searches. This is all great, but here's the big question. How does this system actually get smarter over time? That's where the learning agent comes in. It uses human feedback to teach and improve the whole system. So every single correction makes the entire system better. It doesn't just work, it actually learns. So what kind of tech actually powers this whole thing? Let's pop the hood and take a look. It's a mix of agent frameworks like LangChain, special databases, and tools that can handle massive scale. Okay, so you've built all this. What do you actually get? What can this new system do? You get automatic data extraction, real intelligence across all your docs, and a system that's always learning. This means you can just ask it real questions in plain English. It totally changes how you find information. So, the big takeaway here? We're not just storing documents anymore. We are finally starting to understand them. Let us now see each layer in detail. After explaining each layer in detail, we will start the hands-on lab, showcasing the metadata enhancement project. You know, in banking today, every single document kicks off this massive chain reaction. We're talking metadata extraction, validation, enrichment, storage, you name it. But none of that can even start without the first absolutely critical step. So today, we're going to follow one single loan document through that gateway, the data ingestion and classification pipeline. We're going to see how it goes from just a file on a server to structured, intelligent data. Let's trace its path. So picture this. A PDF gets uploaded, or maybe it's attached to an email sent to the bank. Could be a loan agreement, could be an ID, could be anything. The clock starts ticking. What happens in those first few critical seconds? Well, that question is really what drives the incredible automation we're about to unpack. At its heart, the entire challenge is this. How do you turn unstructured chaos, like a messy, crooked, scanned document, into pure, structured order? We're talking about a clean, machine-readable format like JSON that a computer can instantly grab, understand, and act on. This whole pipeline is engineered to make that transformation happen with some serious speed and precision. Okay, let's start the journey. The very first phase is all about the document's arrival. It's about getting that raw file into the system, no matter where it came from, and prepping it for the real intelligence that's coming up next. Think of this part as the digital cleanup crew. First, an API endpoint, probably built with something like Fast API, is just waiting to catch any file, PDFs, JPEGs, you name it. It grabs it and stores it safely in a service like AWS S3. Then it gets normalized. Tools like PDF-to-image step in and convert everything into a standard set of high-res images. And finally, the heavy hitters, like the OpenCV library, get to work. They fix any tilt, scrub out scanner noise, and crank up the contrast. The goal? A perfectly clean, OCR-ready image. Now that the document is sparkling clean, the system takes its first intelligent peek. Now, this isn't about getting the final perfect answer. Not yet. This is all about making a fast, educated guess, kind of like a mailroom sorter, just glancing at an envelope to see which department it should go to. And to do this, the system doesn't waste time reading the whole document. That'd be way too slow. Instead, it uses a super fast OCR tool, something like Tesseract, to just snatch a small text sample from the first page. It's looking for quick clues, like the words you see right here: loan agreement, borrower name, EMI. These are huge signals. And this brings us to a really key concept: hint generation. Now, the crucial thing to remember is this is not the final classification. It's a quick, probabilistic guess. The system uses a whole bag of tricks. It scans for keywords, it might run the text through a simple machine learning model like fast text, and it even analyzes the basic layout. Is there a big table? Might be a statement. Are there long paragraphs of text? Probably some kind of agreement. Now, what's really cool is the output you see here. The system doesn't just confidently say, it's a loan document. Nope, it gives you a list of possibilities with confidence scores. So here, it's about 72% sure it's a loan document, but it's also saying, hey, there's an 18% chance this could be a bank statement. The top guess, that hint, is what gets passed on to the next stage. But that initial hint, that's just the opening act. The process now shifts gears, moving from a quick guess to a final authoritative decision. It's time to call in the expert, the document understanding agent. This is the more powerful, heavyweight part of the system that makes the definitive call. And this just lays out the core architecture perfectly. You've got the ingestion layer, the sorter, which is built to be fast, probabilistic, and really just assistive. It's there to help. Then you have the agent, the expert. It's built to be accurate, context-aware, and the final authority. It's using the big guns, like Google's Document AI, to understand the full context. Okay, but this is where the system gets really clever. What happens if that quick initial hint was just wrong? What if our sorter accidentally sent the document to the wrong department? The answer is a self-correcting feedback loop. It's brilliant. Let's say the initial hint was something vague, like generic form, but the expert agent looks at it and says, no way, this is 100% a loan document. The system immediately flags this mismatch. That triggers a reprocessing. It basically says, whoops, my first guess was off. Let's rewind and apply the correct, specialized tools for a loan document. So once that final correct document type is locked in, everything that happens from this point on is completely custom tailored. The system knows exactly what it's dealing with, and it can pull the perfect set of tools from its toolbox for the job. This brings us to another great idea called adaptive OCR. And it's pretty simple, right? You don't use a one-size-fits-all approach to reading the document. That's inefficient. Instead, you apply a very specific OCR strategy that you know works best for that particular type of document, all to get the highest accuracy possible. And this table just makes it crystal clear. For a bank statement, right, it's mostly tables, so you'd use a premium table extraction OCR. For something like an Indian Aadhaar card, you need a tool that gets its specific layout and languages, so maybe Google Document AI. And for our loan document, well, it's a mix of dense legal clauses and financial tables, so it needs a special hybrid, section-aware strategy. All right, we are in the home stretch. The document is clean, it's been correctly identified, and the right tools are all warmed up. Now it's time for the final act, turning that page of text and tables into structured, meaningful data. The final extraction pipeline kicks into gear. First, layout detection tools, something like Layout Parser. Slice up the page into logical chunks. This is a header, that's a table, this over here is a key value pair. Then, that hand-picked adaptive OCR strategy gets run on each little region. After that, some post-processing scripts jump in to clean up any garbled text and restore the correct reading order. And finally, it's all wrapped up with rich metadata. And here it is, the prize. The final output is no longer just a messy wall of text. It is a beautiful, structured JSON file. It's got the confirmed document type, the confidence score, and all the content is neatly broken down into logical blocks, tables, key value pairs, everything. The chaos has officially become perfect order. This quote just perfectly sums up the entire philosophy, doesn't it? You have a fast, helpful front end and an accurate, authoritative back end. And when you link them with that feedback loop, you get a system that isn't just powerful, it's also resilient and incredibly adaptive. So what are the big takeaways here? Well, this architecture brilliantly balances the need for speed with the demand for accuracy. It's adaptable, right? It applies the right tool for the right document. It's resilient because it can catch and fix its own mistakes. And, this is crucial, it's intelligent. Every single time that feedback loop gets triggered, it's a learning opportunity to retrain the models and make that initial hint even smarter for the next time. And that leaves us with one last thought to chew on. We've just seen a system that can deeply understand the content of a document. As this technology keeps getting better and better, the next logical leap isn't just processing information, but actually making judgments based on it. So, how long until a system like this can not only read a loan document, but instantly assess its financial risk? Something to think about. You know, in the world of data, nothing is ever quite as it seems. There's this invisible layer, a kind of digital detective that works behind the scenes. It's constantly sifting through information, looking for clues, and figuring out what's real and what's not. Today, we're going to crack open its case file and see exactly how AI makes sure that the data we all rely on is actually trustworthy. So picture this. You've filled out a loan application, you've attached all your documents, and you click that submit button. For you, that's pretty much the end of it, right? Well, in reality, a super deep, multi-level investigation has just kicked off, and we're going to follow that data's entire journey right from the very beginning.
And this is our case file. Meet our applicant, Rajesh Kumar. What you're looking at is the raw data that just came in. At first glance, it seems simple enough, a name, a PAN number, a date of birth. But to our AI agent, this is basically an unverified scene. Every single field is a piece of evidence that has to be checked. And for a big bank, this happens thousands and thousands of times a day.
Okay, so Rajesh's data is about to run the gauntlet. And I mean that literally. This isn't just one simple check, it's a whole series of increasingly intelligent tests. They're designed to catch everything from a simple typo all the way to some pretty sophisticated fraud. So, here's the roadmap for our little investigation. We're going to start with the basics, these field-level checks. Then we'll get smarter with something called a semantic check. After that, we'll connect the dots across different documents, hunt for any signs of fraud, and finally, we'll give the data a score based on how confident we are in it. Let's start with that first hurdle, the format check. The very first line of defense is format validation. Honestly, the best way to think about it is like a bouncer at a club door. It really doesn't care who you are, it just wants to see if your ID is in the right format. Does a phone number have 10 digits? Does an email have that @ symbol? And for something like a PAN card, the rules are even more specific. And this is the secret weapon for that check. It's called a regular expression, or regex. It looks kind of complicated, but it's just a simple rule written in code that acts like a perfect template. It instantly checks if Rajesh's PAN number follows that exact pattern. 5 letters, then 4 numbers, and then 1 last letter. If even a single character is out of place, bam, it's flagged immediately. It's a lightning-fast check that is right 100% of the time. So, the data passed the first test. The format is correct. But does it have the right meaning? This is where our AI starts to think less like a bouncer and a lot more like a detective. Semantic validation goes way beyond just looking at patterns. It tries to understand the context and the nuance, kind of like a person would. Now, this is the really cool part. The system literally just asks a large language model, the same kind of AI that powers things like ChatGPT, a plain English question. It just shows it 2 different names, Rajesh Kumar and R. Kumar, and asks, hey, are these the same person? The AI just gets it. It understands abbreviations and common name formats in a way that rigid, old-school code just can't. Okay, our detective now has a few pieces of evidence. There's the application form, an ID card, a bank statement. Cross-document validation is basically the process of laying all of those out on a table and looking for contradictions. I mean, if Rajesh is who he says he is, then his key details should be the same everywhere, right? And boom, our detective finds a clue. The name, Rajesh Kumar, matches perfectly across both documents. That's great. But look at the date of birth. The loan doc says January 1st, but the Aadhaar card says January 2nd. Now, this is a really critical mismatch. It doesn't automatically mean it's fraud. It could just be a typo, but it's a huge red flag that has to be recorded. Okay, so with that potential inconsistency found, the agent now puts on its fraud detection hat. It's not just checking for simple errors anymore, it's actively hunting for suspicious behavior. This means it's searching for patterns that don't look normal or that break the company's own business rules. Here's a perfect, simple example of that. The system might have a rule that says, hey, a loan amount should never be more than 20 times the applicant's annual income. So if Rajesh's income and the loan he's asking for are wildly out of balance, the system immediately raises a high-risk flag. It's a simple check, but it's a super powerful way to catch applications that just don't add up. So our agent has checked all the formats, it's understood the meaning, it's compared the documents, and it looked for fraud. What now? Well, now it's time to pull all of those findings together. The goal here is to turn this whole complex investigation into a simple, easy-to-understand measure of trust. And the detective does this with something called confidence scoring. Every single field gets its own score. This isn't just a gut feeling. It's a number that's calculated based on all the evidence we've gathered. Things like, How clear was the original document scan? Did it pass all the validation checks? And was it consistent across all the different sources? This here is a simplified look at how that score gets calculated. You can see that different things are given different weights. The quality of that first document scan, what we call OCR, or optical character recognition, that's often the most important factor. In Rajesh's case, that date of birth mismatch means his consistency score would be really low for that field, and that would drag the final confidence score way, way down. The very last step in this whole analysis is to build something called a validation graph. Now that sounds super technical, I know, but it's really just about creating a clear map. It connects the main person, Rajesh Kumar, to all of his data points and documents, creating one single unified profile from all those scattered pieces of information. And this is basically what that map looks like, see? It's a really simple logical flow. Rajesh Kumar is linked to his PAN number. That PAN number is then linked to all the documents where it shows up. This little web of connections confirms that all these pieces of information belong to the same person, giving us a complete picture of the applicant. And with that, the investigation is complete. The digital detective has run all its tests, it's scored all the evidence, and it's mapped out all the connections. Now it's time to deliver the final report, turning that initial mess of raw data into absolute crystal clarity. And here it is. Just take a second and compare this to that simple file we saw at the very beginning. Now, each field doesn't just have a value, it has a confidence score. And, most importantly, that date of birth field has a mismatch status clearly flagged for everyone to see. This isn't just data anymore, it's intelligence. It's an actionable report that the next system, or maybe a person, can use to make a really smart, informed decision. So when you really think about it, this digital detective isn't just a fancy spell checker. It's a gatekeeper of truth, making sure everything is accurate right from the start. It's a consistency expert, ensuring the whole story adds up. It's a fraud detector, always watching for those red flags. And I think, most importantly, it's a confidence generator, creating a trusted foundation for every single decision that comes after it. Which leaves us with a pretty fascinating thought. We've just seen how an AI can totally master this meticulous, investigative role of a detective, right? It's an unbelievably powerful tool for finding the truth in our digital world. So the real question is, what other human job that relies on judgment and investigation and trust is this gatekeeper of truth going to redefine next?
Hey everyone, and welcome to The Explainer. Today we're going to talk about a really cool piece of tech. Something that takes just plain, simple data and turns it into some seriously powerful intelligence. So put yourself in this situation. Imagine you work for a bank, right? And this loan application lands on your desk. You've got a name, an address, a loan amount, and that's pretty much it. I mean, is that really enough to decide on a loan worth lakhs of rupees? Probably not. Let's dig into how we can get a much clearer picture. Okay, so here's what we're going to cover. First, we'll talk about why raw data can be such a headache. Then, we'll meet the intelligence layer that solves the problem. We'll check out its cool toolkit, follow our loan application from start to finish, and finally, see how it all comes together to make a real decision. All right, so the solution to this data puzzle isn't just some magic black box. It's actually a super important step in a bigger process. We call it the intelligence layer, or more specifically, the enrichment agent. So what is this enrichment agent? Well, think of it this way. Its job isn't just to see if the data is correct. No, its job is to make that data smarter, to connect the dots and make it way more useful for making actual real-world decisions. Now it's really important to understand where this agent fits into the whole pipeline. Data first gets pulled in, then information is extracted, and then it's validated to make sure it's accurate. Then, after all that, comes our enrichment agent. It's kind of like the genius final step in the assembly line. Okay, so how does this agent actually do its magic? Well, it's not just one simple trick. It has this whole toolkit of powerful techniques it uses to get the job done. It's actually a mix of a bunch of cool things. You've got your basic stuff, like cleaning up names and text. But then it gets really advanced, using large language models, LLMs, to understand the context of the data. It even reaches out to external APIs to grab things like geolocation data. And get this, it does something called feature engineering, which is a fancy way of saying it creates brand new useful insights from the data it already has. And on top of all that, it runs its own machine learning models to figure out tricky stuff like risk scores or income. All right, let's make this real. we're going to follow our applicant, R. Kumar, and see exactly how this toolkit takes that simple data file and completely transforms it, one step at a time.
First things first, let's look at the name. R. Kumar. I mean, who is that? It's pretty ambiguous, right? So the first job for the agent is to figure that out and standardize it. So this is what the agent gets to start with. It's super simple, just a little snippet of data that says name is R. Kumar. That's it. That's all it has to go on.
And check this out. This is the output. Using one of those LLMs we talked about, it expands the name to Rajesh Kumar. And it even tells us how sure it is, with a confidence score. Just like that, we have a much clearer idea of who we're dealing with.
Okay, next up is the address. Sector 62, Noida. Again, that's pretty vague. Where's the state, the country, the PIN code? And this isn't just about sending mail. A vague address is a huge gap where things like fraud could hide. And just like with the name, the agent starts with something really basic. The raw input is just that one little phrase, Sector 62, Noida. Nothing else. But watch this. By calling out to an external Geo API, it transforms that vague phrase into a full standardized address. It adds the PIN code and even the exact latitude and longitude. And again, this isn't just for putting on a map. This is absolutely critical for things like location-based risk assessment.
All right, now we get to the big question, the one that really matters. Can this person actually afford the loan? To figure this out, the agent is going to dive into their bank transaction data. And this is where things get really smart. The agent doesn't just add up the numbers. No, it intelligently scans the entire transaction history, looking for patterns. It's trying to find recurring credits, like these two here for $50,000 and $52,000. It sees their labeled salary and they come in regularly. That's the classic fingerprint of a monthly income. So what does it do? It crunches those numbers, calculates an average, and comes back with an estimated monthly income, 51,000 rupees. And once again, it gives a high confidence score. Suddenly, the bank has a very clear, data-driven answer on affordability. Okay, last step. The agent takes everything it's learned so far, the correct name, the precise location, the estimated income, and it pulls it all together to create one single unified risk profile. And remember that feature engineering thing we mentioned? This is where it happens. The agent takes the income it just figured out, compares it to the loan amount, and creates a brand new piece of information, the loan-to-income ratio. This new metric, along with how stable those salary payments are, is absolutely essential for understanding the real risk. So the final result of this task is a clear risk profile. It says medium. But what's so important here is that it's not a mystery. The agent actually explains why it came to that conclusion. It lists out the contributing factors, both good and bad. This kind of transparency is a game changer for the loan officer who has to make the final decision. They need to know the why. So let's step back. After all of that work, what does our little data file look like now? I mean, just look at the transformation here. It's amazing. We started with just a couple of vague lines of text. And now? Now we have this rich, structured profile. It's got a confirmed identity, an exact location, verified financials, brand new insights like that loan-to-income ratio, and a risk score that you can actually understand and act on. And that, right there, is the whole point. It really gets to the heart of it. Raw data, that's just the beginning. The real value, the magic, happens when you turn that data into intelligence. Intelligence that lets you make decisions that are not just smart, but also fast and fair.
So I'll leave you with this question to think about. What problems in your world, in your work, could you solve if your data wasn't just correct, but was actually truly intelligent? Thanks for joining me on this explainer. All right, today we're going to pull back the curtain on something really cool, how we take raw, enriched data and turn it into a powerful, searchable, intelligent system. We're going to look at the magic that happens behind the scenes, the stuff that makes huge amounts of information instantly useful. So, here's our plan. We're actually going to follow one single piece of data on its entire journey. We'll start with its final transformation, walk through the 6-step blueprint, see how it gets connected and broken down, and then how it gets its own unique digital fingerprint. After that, we'll see how it's organized, and finally, how it gives us real, actionable insight. Okay, so imagine this. You've done all the hard work of collecting and cleaning up your data. It's all there, it's tidy, but the big question is, what now? How do we get from this big pile of information to something that's actually intelligent, something we can ask questions to.
And that is the big question, right? To make this super clear, we're going to follow a real-world example through this whole explainer. Let's meet our hero for today, a loan application for a customer named Rajesh Kumar. His data is clean, but it's not smart yet. So let's go ahead and change that.
Okay, so here it is. This is our blueprint, the high-level roadmap we're going to follow. It's a 6-step plan for taking Rajesh's simple loan document and turning it into a goldmine of searchable intelligence. These 6 steps, linking, chunking, generating embeddings, structuring metadata, storage, and finally index creation, that's the whole pipeline right there. Now, let's break down every single one of these step by step and see exactly what happens to Rajesh's loan document along the way. All right, first things first, we gotta start with the foundation, and that means our first 2 steps. Before we can do anything fancy, we have to create clear connections in our data and then break it down into smart, manageable pieces. You know, the very first thing we have to do is play matchmaker with the data. We need to create a unified graph that clearly says, this customer, Rajesh Kumar, is connected to this loan and these specific documents. It's all about connecting the dots and creating a single source of truth for every customer. So this is what we start with. It's the raw material our system gets. As you can see, it's structured, but the pieces aren't explicitly connected. We have a customer ID for Rajesh, some info about his loan, his risk profile, and a path to where his loan document is sitting in cloud storage. And boom, look at this. After that first step, the system has created a direct, explicit link, a graph really, that connects Rajesh's customer ID to both his loan ID and his document ID. Now everything is officially tied together. Okay, step 2, smart chunking. This is so important. See, instead of treating Rajesh's entire loan document as one giant blob of text, which is awful for searching, we break it down intelligently, and smart is the key word here. The system actually understands the document's structure, the headings, the tables, and creates these smaller, meaningful chunks that each hold a specific piece of context. And this is what it looks like in practice. Rajesh's document isn't one big wall of text anymore. Now we have these distinct chunks. We've got one for the borrower's info, another for the loan summary, and a third for a specific transaction. It's this level of precision that makes our search so incredibly powerful later on. Okay, so our data's linked up and broken into these neat little pieces. What's next? Well, now we have to translate these text chunks into a language a computer can actually understand and attach some useful, searchable labels. This is where we create the data's digital fingerprint. This step, embedding generation, honestly, it feels like pure magic. We use these incredibly powerful models, like the ones from OpenAI, to convert each text chunk into a long list of numbers. We call this a vector. Think of it like a unique GPS coordinate for that chunk on a giant map of meaning. This lets us find similar concepts, not just search for specific keywords. So what does that actually look like? Well, that little snippet of text from Rajesh's loan summary, loan amount 500,000, EMI 10,000, gets transformed into a long list of numbers that looks just like this. This string of numbers becomes its unique digital fingerprint, representing its actual meaning. But meaning alone isn't enough, right? We also need the hard facts. And that's what metadata structuring is all about. We attach these structured labels like the customer ID, the document type, the transaction amount, that we can use for really precise filter-based searches, almost like you would in a traditional database. And just look at all the critical metadata that's now attached to Rajesh's document. We've got his customer ID, his loan ID, the document type, even his risk profile. This is the key to unlocking really powerful hybrid searches, queries that combine both meaning and facts. So you could ask something like, show me all high-risk clients with loans over 500,000 whose applications mention the idea of payment delays. That's a game changer. All right, we're getting close. Our data has its fingerprint, it has its labels. Now we need to put it somewhere safe and, more importantly, make it ridiculously fast to find. It's time to build our digital library. Now, we don't just dump everything into one big box. We use a really smart 3-tier system where each part has a very specific job. The vector database, something like Pinecone, that stores all the vectors for understanding meaning. Think of it as the librarian who knows the concepts in every book. Then, a structured database like Postgres stores the metadata for filtering by facts. That's like the detailed card catalog with the book's title and author. And finally, object storage like Amazon S3, that's the actual library shelf that holds the original files themselves.
And the last piece of the puzzle is creating the index. This is like creating a hyper-efficient digital card catalog for our entire library. We use these advanced techniques like approximate nearest neighbor indexing, or ANN, which makes it possible to search through millions of these vectors and find exactly what we need almost instantly. So, after all that work, after all 6 of those steps, what do we actually have? Let's take a look at the final, fully search-ready system that now holds all the intelligence from Rajesh Kumar's application.
Well, this is it. This is the finished product. It's a fully indexed, deeply interconnected representation of Rajesh's data. His customer ID is linked to his document, which has its own vector, and that document is then linked to all of its individual chunks, which also have their own unique vectors. It is now ready for any question we can possibly throw at it.
I love this next part because it really just boils everything we've talked about down perfectly. We search for meaning using the vectors. Our system then retrieves the proof from the original documents. But ultimately, we deliver the value, the answer, in the context of the customer. It's that simple. And that really leaves us with one big, exciting question. With a system like this in place, one that can understand meaning, connect dots, and filter on facts, what incredible new questions could you finally ask of your own data? Thanks for watching.
Like and subscribe for Simplify Tech, explaining one concept at a time, simplifying the technology and AI.